Hello everyone. Today's topic is the introduction to artificial neural network and its application. So, firstly, in the artificial ANN, artificial neural network is the type of the perceptrons. So, artificial neural network are the fundamentals building blocks of modern deep learning system. They consist of interconnected artificial neurons organized into layers and that learn from training data to organize patterns, make prediction to solve complex problems. So ANN is like the going to the one node to another node data. It's like the ANN artificial neural network. So in the ANN organized into input hidden and output layers, layer by adjusting weights and bias during training, process data through forward propagation and improve using back propagation. Forward propagation means your data sending to the forward way, and backward propagation means your in the perceptron your data sending to the backsides, like for say multiple hidden neural layers. So first is the first hidden layer, and the second is the second layer too. Okay, form the foundation of advanced deep learning architecture such as CNN and RNN and transformer. And in the artificial neural network, CNN used for image processing, image transforming, and RNN recurrent neural network. Recurrent neural network use the store the memory in the artificial neural network and using the storing memory and give the output. And transformers transforming the data. Transformers use the modern technology and is the use the transformers use the embedding, like your data words, embedding the data in numerical 0110 or matrices. So how to working artificial neural network? So artificial neural network here is a human brain process information processing in the consistence of input hidden and output layers, learns pattern and make prediction from data. It's all about learn patterns and make prediction from data. In the artificial neural network is the three layers: input layer, hidden layer and output layer. Input layer and output layer only one layers, but hidden layers you will create the multiple layers, like 1 2 3 4 multiple layers, 10 layers, 15 layers. So okay, first is the input layer. Input layer use give the data input layer 1 2 3 4 5, and it's in the hidden layer. Hidden layer is one layer, second layer, third layer, and it in the hidden layer we use the neurons. It is the neurons, and it's and it is the line of the weights. Input data sends the weights through weights through data, and data in the neurons we will type of in the neurons processing is half of the is the use the regular the activation function, and half of uses the mathematics, like where weight plus x1, weight into x1 is the use the in neurons. So multiple neurons create the it's a way to forward propagation, like it's a input layer sending the this neurons data, this neuron sends to another hidden layer neuron data. It is called as forward propagation. And backward propagation means it is this neuron sends this neuron sends the data to this neuron. It's called through weights, it's called as backward propagation. And it's I will say the hidden layer, feed forward layer, and output layer. Difference in actual value output layer. Okay, so types of neural networks in the neural networks, perceptrons, types of feed forward neural network. Feed forward networks is the जुनी it's a old technology. Feed forward neural network. And conventional neural network CNN use the image processing, and recurrent neural network is the storing the memory and give the access. So it is called as. And in this neural network is the artificial neural network use the social media, healthcare, finance, personal assistant, marketing, retail, or chatbot, or all over. So firstly, in the artificial neural network, first mathematics formula evaluate in 1943. M. Koloch Pitts, it's a name of scientist, model of neuron. One of the earliest model of artificial neuron. It's the first model of artificial neural network is created in 1943. So neurons was the M. Koloch Pitts model introduced in 1943. It is also known as the linear threshold gate. And in this artificial neural network, the neuron takes multiple inputs, each associated with the weight. A weight sum of the inputs is calculated, but if the weighted sum exceed threshold, the neuron feels here output 1, otherwise it doesn't not fire output 0. So mathematically this is represented by f of y in is equal to hyphen 1 0, if it's called as mathematical formula. And this model laid to foundation of modern neural networks. It's not for important. It's only first model of the 1943. So not any more important in this mathematics. You will see the mathematics of new technologies, RNAs, ANN, artificial neural network, RNN, or CNN, federal neural network. It's old technology. So first, what is the algorithms? So in the artificial neural networks algorithms, initialize weights and bias. Weights means you send the data to one neuron to another neuron, and bias means I will say the algorithm started by initializing the weights. Weight sends to one neuron to another. The strength of connection between neurons and biases. Bias means one neuron and another neuron's distance, which is the additional parameter that help to adjust output. These values are usually initialized randomly. You also set the learning rate, which controls how much the weight should be adjusted during training. These values also set the learning rate is alpha, which controls how much the weight should be adjusted during training. So feed in input data. The input data is fed into the input layer of the network. Each input is a feature link, like an image pixel value from a dataset. Forward propagation, I also says ki forward propagation, sending to the one neurons to another neurons forward way, left to right way. The data is passed through the network from the input layer to the hidden layers and finally to the output layer. At this layer, input is multiplied by the weights and passed through an activation function like sigmoid ReLU. An activation function means sigmoid is the activation function means create, you will sending the, okay, I will explain it. What is meant by activation function? Activation function means in this neuron we will use the activation function, like use the ReLU. Is the activation function ReLU sending the multiple data to this another neurons? So another neurons, it's called as activation function. And activation functions, multiple activation functions: sigmoid, ReLU, tan, softmax. So feed forward calculator error, okay, I will say the like sigma ReLU etc to produce output of that layer. The result is a prediction or an output that is compared to the actual target value. Calculate error. Once the network has made a prediction, that next step to calculate the error. Example, difference between the predicted output and the actual target. This error is often measured using a loss function like mean squared error across entropy. So I will say back propagation. What is meant by back propagation? And back propagation is the major work of in artificial neural networks. Update the weights. Any loss, any in the weights, removing the data, less the data. It's the back propagation updates the weight. Back propagation computes the gradient. Example: how much changes in weights would reduce the error by using the chain. Rule of calculus: the weight and bias are updated to minimize the error. The update is done using the optimization algorithm, and the gradient descent is the algorithm to minimize the loss value. So repeated epochs. Epochs means you will go into the one all one forward propagation and one backward propagation. Back propagation is the one forward propagation and one backward propagation is the one epoch. So step 2 to 5 or repeated for multiple epochs, which is iteration over the entire training data set. During each epoch, the weights are adjusted to reduce the error gradually. Test the network. After training the network, you will use the matrix or something else to evaluating the performance. After training, the network is tested with the new data to evaluate its performance. If the accuracy is good, the training is considered complete. If not, more training or adjustment may be needed. How do artificial neural network learn? How artificial neural network learns by repeatedly improving their prediction from training examples using the back propagation and forward propagation. Consider the task recognize cats in image. The network is trained using the thousands of labels images, cats and non-cats. Each image passes through the network to generate a prediction. The predict result is compared with the correct label. To calculate the error, the network updates its weights the bias and reduce the error. So is the useful of artificial neural networks. And common activation functions in the end, I will say the activation function sending the multiple neurons to data, and use the activation function, reduce the loss function. So activation function are important in neural network because they introduce nonlinearity and helps the network to learn complex patterns. Let's see some common activation function used in ANNs. Sigmoid function. Firstly, sigmoid function. Sigmoid function use the 0 and 1 only in the output layer. So in the I will say in many layers I will explain in hidden layer I will use another activation function, and in output layer I will use another activation function. So output value between 0 and 1, it is used in a binary classification task like deciding if image or cat or not, spam or not spam in the email. ReLU, rectified linear unit, a popular choice of hidden layers. In return, the input of positive and zero otherwise. It helps to Washing gradient problem. I will say the many multiple data to send the another neurons. 10. Hyperbolic tangent, similar to sigmoid but outputs values between -1 and 1. It is used to in hidden layers when broader ranges of outputs is needed. Softmax is the another version of sigmoid, but softmax use the say we are sending giving the multiple classifications like cat, man, dog is the three classification. And so sigmoid use the only cat or not cat, spam or not spam. And in the softmax use the cat, dog, man, etc, etc. So converts the raw outputs into probabilistic use in the final layer of network for multiple classification tasks. Leaky ReLU, a variant of ReLU that allows the small negative values for inputs, help in preventing dead neurons during training. So the function helps the network decide the whether to activate neurons, helps it to recognize patterns and make prediction. So optimization algorithm in ANN training. So in the I will say the optimization algorithm like activation optimization algorithm is used in deep learning for giving the better prediction value. So optimization algorithm adjusts the weights of a neural network during the training to minimize errors. The goal is to make the network prediction more accurate. Let's see key algorithms. Let's see more algorithms. Gradient descent. Firstly, gradient descent, most basic optimization algorithm that updates weight by calculating the gradient of and the loss function reduce. So Adam, and I will say loss function. Loss function means your actual value and predicted value. Difference between these values. So Adam, Adam is the most popular optimization algorithm in use the deep learning, an efficient version of gradient descent that adapts the learning rates for each bits used in deep learning. RMSROP, a variation of gradient descent that adjusts the learning rates based on the average of recent gradient. It is useful in training recurrent neural network. And stochastic gradient, another version of gradient descent, updates weights using one sample at a time, helps in make it faster, more noisy. And applications is classification, regression, healthcare, business and recommendation system. Advantages use the better finding out the better patterns, handle noisy and incomplete data without affecting their performance. Even if there are errors in the training data, they can still produce accurate result. Once trained, ANS can evaluate functions very quickly, making them ideal for real-time application like self-driving cars or fraud detection. Handle large amounts of data through distributed processing, similar to how the human brain works. And limitations is overfitting, underfitting. Can overfit to training data, especially when the model is too complex or when there is inefficient data, and require large data set for training the general as well. Training deep neural network can be computationally expensive and time consuming, hence requires substantial hardware. Okay, thank you. I will also explain the all neural networks, and another video I will explain theory or plus practical way. Okay, thank you.